Hi, Amy Suggs again. We are here to continue on with section 1.2. Last time we learned about what a function was, relations, looking at domain and range. In this section we're going to look at evaluating functions as well as doing some graphing of functions. So first thing, we're going to talk about functions and function notation. Function notation, what you will see is there is now an f of x that has replaced y. It is not anything to be alarmed with. It doesn't mean anything, just that if we have y equals 2x minus 3, what you are now going to see is you're going to have f of x equals 2x minus 3. So in place of the y, you are just going to have a different notation with the f of x. You don't do anything with the f or the x. You're not trying to divide or solve by any of that stuff. I know sometimes people get a little confused. That just means a function of x. That's all that is. Also, when we evaluate functions, instead of saying let x equals 2 in the equation, we're going to say find f of 2. So finding f of whatever the number is, that's what we're going to do. We want to make sure that whatever value gets put into that equation must also match over there. So what we would do is we would have f of 2 is equal to 2, and in place of the x in the parentheses, we would match it with the corresponding 2. You would then go through and solve 4 minus 3. So f of 2 is equal to 1. That's what we would have. What does that mean, you ask? Well, what that corresponds to is if we were looking at a graph of this particular function, that would correspond to the coordinate, the ordered pair, 2, 1. 2 being the x coordinate, 1 being the y coordinate. 2 is your input, y is your output. So let's do some more. Let's practice. Given the function negative 3x minus 8, we want to find f of a. All we're going to do is take our function, and what I do is I take out the variable and I replace it with parentheses. And so whatever you have on the left side over here in place of x has to match to the right side. So we have negative 3 times a minus 8. All we can do with that is multiply. So I have negative 3a. I can drop the parentheses, minus 8, and that would be my answer. I can't simplify that anymore. And that's what you're going to have right there. So if you want, you can pause this, try the next one on your own, and then come back when you're finished and see if you got it right. So we can go and we have negative 3. I'll have my parentheses with minus 8. Negative 3 on the left, I'm going to match it with the negative 3 on the right. I want to simplify. Negative 3 times negative 3 is positive 9. So I'm going to have 9 minus 8, and that's going to end up being a positive 1. So f of negative 3 equals positive 1, and that is our answer. Negative 3 is the input. It's what we substituted into the equation. Y is the output. It's what we got out from the function or the equation. So to step it up a notch, we have a slightly larger function. We have x squared minus 6x plus 11. No need to be alarmed. We're going to go through this in the same manner. What I want to do is everywhere I have an x, I'm going to use parentheses. So I'm going to have my parentheses squared minus 6 with some more parentheses plus 11. Everywhere you had that x or you had that parentheses, you need to substitute in the value that they've given you. So 4 is our number. That's going to go into the parentheses on both sides. simply going to simplify, do our math. 4 squared is 16. Negative 6 times 4 is negative 24, and then our plus 11. Keep going through. We're just going to keep adding. Always remember order of operations. We're going to go from left to right. 16 minus 24 is negative 8. Of course, if you're using a calculator, you could do this a little bit quicker. Negative 8 plus 3 plus 11 equals a positive 3. So we have f of 4 equals 3, and that is our answer. And just to show you once again, as we could do with any of the others, how it translates into a ordered pair, that would be 4, 3. If I have f of x equals y, that translates into the ordered pair x, y. Okay? I'm showing you all of this stuff for a reason. It's going to make a huge difference. So that's why I want you to get used to rewriting the ordered pairs, making sure you know what's the x and what's the y. It makes a difference. It's important stuff. Okay, one more, a little bit bigger. Same function, x squared minus 6x plus 11. We are going to find f of x plus 1. I'm going to treat that the same way I just did the previous one. I'm going to have parentheses squared minus 6 times my parentheses plus 11. We have x plus 1 here on the left. I must put the x plus 1 into the parentheses, both sets, on the right side. This squared here, that implies x plus 1 times x plus 1. You have to FOIL that out. Okay, it's not just square both of those numbers and you're done. We need to make sure that we go through FOIL. We have x squared for our first outer, 1x. Our inner is 1x, and our last will be 1. Then we're going to take that negative 6 and distribute it to the x as well as the 1, so we get negative 6x minus 6. And then don't forget about the 11. We're just simplifying, so I just need to combine all of my like terms. I have x squared, x plus x, that's going to give me 2x. And 2x minus 6x is going to be negative 4x. Then I have 1 minus 6 is negative 5, and negative 5 plus 11 is a positive 6. Double check my math real quick. I think I'm good. If I had students here, I could ask you to do this for me, but I'm all alone. Oh well. And so that is it. You're not solving, you don't factor. You leave it just like that. That's your answer, okay? All right, so evaluating functions, just make sure you pay attention to the value they want you to substitute in, and then you evaluate the function with whatever function they give you, whatever equation, all of that. So next up is going to be the graphing. Still evaluating a function, but we're going to actually graph it. We're going to do something with it. So our first equation, what I've done is we have our given x values. They could give you x values, tell you to use specific ones. If not, pick whichever x values you want. I always say pick at least 2 to 3, gives you a good idea. But when you're working with lines, straight lines as most people call them, but all lines are straight, you really only need 2 points. 2 points are good. Try to space them out a little bit so they're not all next to each other. If you have a function, you're not sure exactly the shape of it, I would highly recommend that you use more points. The more points, the better representation of the graph you're going to get. So you might need to use 3 points, you might need to use 5 points. It just depends on what kind of equation you're given. What we're going to be working with here is all lines. So y1 equals x, So what that means is whatever I have for x, I'm going to substitute in. So if my x is -2, then my y is -2. If my x is 0, my y is 0. And if my x is +2, then my y is +2. So each of those, my coordinates, as you can see, I have a table. A table is nice for graphing. I think it works well. So those 3 points, that's going to be my y1. I'm going to do that in black. So I have my nice grid here. If you want to use graph paper works wonderfully with this stuff. It helps you keep everything nice and neat. So -2, -2, you see my x is -2. X is always your horizontal. And then I just drew over it. That wasn't very smart of me. But over here, I just want you to see x is your horizontal, y is your vertical. So from the origin 0, 0, I would go to the left 2, that's my x, down 2, that's my y. 0, 0 is our next point, and that is at the origin. Last point, +2, so I'm going to go to the right 2, and then up 2. So there's my third point. I'm going to get my straight line and hopefully make it look pretty. I like all of my graphs to have arrows because graphs continue on forever. They are infinite. Okay. So let's look at the second graph that we have, second equation. It's similar, just a little different. So y2 is x plus 3. So the difference I have here is every x value that's going in, I'm now adding 3 to that. -2 plus 3 is going to be +1. So that's going to go there. 0 plus 3 is +3. That's my second y. And then 2 plus 3 is a +5. So my 3 ordered pairs, my 3 coordinates, let's see, -2 and 1, 0 and 3, 2 and 5. All right, so now I want to plot those. I'm going to do that in a different color. Oh, hold on. Let me fill in my chart. There we go. Put the 5 on there. All right, so plotting my points. -2. This time my y value is 1, so I'm going to go up 1, and that is going to be my new point. 0, 3, I'm start at the origin. My x is 0. I'm just going to go up 3 so that I have my new points on the y-axis. Then +2 and +5. So I go over where x is 2. I then go up to 5. And there is my third point. Get my nice edge, draw my line, and my arrows. And there you have it. So if we were to compare these two graphs and we wanted to say, how do these two graphs differ? Well, the original graph is going to be my y equals x, and my second graph here is 3 units higher. The y values are all 3 units above of what the original graph is. So the new graph, the red one you can say, or y2, has been shifted up 3 units from the previous one. Okay, so let's do another example of this. And once again, if you would like, I always recommend you see what we have, pause the lesson, try it on your own, and then come back and compare what you have to what we do. Okay, so I have pretty much my first equation, y1 equals x, is the same as we did previously. So we have the points there, -2, -2. We have 0, 0, and +2, +2. So when you have a table, it just compares to ordered pairs in that manner. I'm going to plot -2, -2, 0, 0, +2, +2. I then going to draw my lovely line, and there I have it. Okay, I have to erase that, as that is just not straight. I might get, it only halfway went through my points, so I like to make sure that my line is accurate. And that's why graph paper is really nice. I still did it's okay. Y'all won't tell on me, will you? All right. So I'm going to erase this. Let's go to our y2 now. y2, as you see, is x -2. So I'm just going to be subtracting 2 from each of my x values. So if I substitute in -2, -2 minus 2, that's going to give us -4. If our x is 0, 0 minus 2 is -2. Putting that up in my chart. Then we're going to have an x value of +2. 2 minus 2 is 0. So now my 3 ordered pairs, -2, -4, 0, -2, and 2, 0. I'm going to go to my other color, -2, -4. So I'm going left 2 from the origin down to -4. Then I have 0, -2, so from the origin I'm going down to -2 right there on the y-axis, and then +2 zeros. So once I go to the right 2, my y is 0, I'm not going up or down, so I'm going to be right there on my x-axis. I'm now going to graph, draw my lovely line. I did a better job of hitting all my points. And there you have it. So if I'm going to compare these two lines, the red line, my new one, in comparison to the original, is 2 units down. All of the y values, whatever they were, no matter what x values I used, all of those y values have now been shifted down 2 units. On the previous graph, we want to go back and look at it real quick. Remember, they went up. They shifted up 3 units from the original graph. Okay, so it just depends what your original graph is, what you're looking at. If you go up or down, in this case we went down 2. There's a lot of different types of shifting that can be done. Okay, so that's how we graph. So that is going to conclude this second piece to section 1.2. And then next, we're actually going to be looking at graphs of functions and getting information from them. So I will see you later. Bye.